Hi guys, today we're going to be talking about phase changes. What exactly is a phase change? Well, a phase change is just when a substance changes between being a solid, a liquid, or a gas, and it changes into some other state. Some of the examples is like, say you heat up a block of ice. It won't simply get warmer, it would also melt and become liquid. And if you keep on heating this liquid, it will boil and become gas. So that talks about our first phase change, is when a solid is melted through its melting point, and it melts and turns to liquid. So that's what this arrow shows, is the melting point, how the solid is heated through its melting point and turns into liquid. And the next one we'll talk about is how some substances cannot exist as a liquid at certain pressures and will sublimate instead, turning directly from a solid into a gas. And this is only because they cannot exist as a liquid at these certain pressures. And if a liquid, let's say, is heated through its boiling point, so this is a boiling point right here. I'll use a B to symbolize that, and this is a melting point, M. So what happens when a liquid is heated through its boiling point? Well, we saw in the last example with the ice, and it just vaporizes and turns into gas, and we call this stage vaporization, and this stage is called a sublimation, and this is just called melting. And the next one I want to talk about is if a gas is cooled through its boiling point, then it'll obviously turn into liquid. The term for this is called just condensation. Condensation is when a gas is cooled down through its boiling point to a liquid. And in some examples, the gas will deposit into a solid, and this one's called depositation. And if a liquid is again frozen past its melting point, then it will just turn into solid. This is called freezing. So those are all our stages. It's not as important to just memorize all. Oh, by the way, if you didn't know, this was a gas, this was a liquid, and this is solid. But I feel like it's more important to understand the equations and the temperature changes that go with the phase change. So let's erase all of this and we'll talk about that. Okay, next, Q. What is, Q in this case is not heat, but here we're talking about the latent heat of transformation. This is a latent heat of transformation, and it tells us how much heat it takes to change the phase of a substance. So, for example, let's say the latent heat of fusion of water which is the latent heat of fusion is the latent heat gained or lost in transforming a solid into a liquid or a liquid into a solid. So it goes both ways. And if the latent heat of fusion of water is 3.3 times 10 to the 5th or some other value joule per kilogram, that means it takes that much energy to change 1 kilogram of ice into water. And it takes the same amount of heat, and to remove the same amount of heat to change 1 kilogram of water into ice. And during this fusion state, the temperature will remain constant at 0 degrees. So the latent heat of fusion tells us the latent heat gained or lost in transforming a solid into a liquid or a liquid into a solid. Well, what about from a liquid into a gas? Well, that's called the latent heat of vaporization. And it's the same symbol here. And latent heat of vaporization tells us how much heat is gained or lost in transforming a liquid into a gas or a gas into a liquid. And this value is different from the heat of fusion. For water, so let's remember for H2O, the Q of fusion was 0.3 times 10 to the 5th. And how about for Q of vaporization? Well, instead this is now 2.3 times 10 to the 6th, which is greater. And the units for latent heat are joules per kilogram, because that just tells us how many joules it takes to, how many joules of heat you have to remove to turn a solid into a liquid. Oh, sorry. This tells us how much heat gained or lost in transforming a solid into a liquid or a solid into a solid. And remember that the 3.3 tells us that it takes 3.3 times 10 to the 5th joules of energy to change 1 kilogram of water ice into water. And also, you have to remove this 3.3 times 10 to the 5 joules to change 1 kilogram of water into ice. And throughout these changes, T is a constant. What does the 2.3 times 10 to the 6 joules over Coulomb mean for vaporization? Well, that just means you have to add 2.3 times 10 to the 6 joules to change 1 kilogram of water into gas, or to remove the same amount of heat to change 1 kilogram of gas into water. And this temperature will remain constant at 100 degrees Celsius because 100 degrees Celsius is the boiling point of water. And to sublimate, which means that that you turn directly from solid into gas, you need an amount of energy equal to the sum of the latent heat of fusion and the latent heat of vaporization, because you go through 2 steps. So let's do a practice problem. In our practice problem, let's say that how much heat is needed to transform a 1 kilogram block of ice at -5 degrees Celsius to a puddle of water at 10 degrees Celsius. So let's write this problem out. It's 1 kilogram of ice at -5 degrees Celsius into, so you're transforming into a puddle of H2O at a temperature of 10 degrees Celsius. How much energy is required? Well, first, there are 2 phase changes. First, you know that the melting in the ice into water, or the melting point, because the freezing point of water is 0 degrees Celsius, so that's when the first phase change will happen. The first phase change will happen when the ice turns into water, and that happens at 0 degrees Celsius. So the first equation we're going to use is Q equals mc delta T. And this is to 0 degrees Celsius, because 0 is the freezing point of water. And if we plug our values in, we get 1 kilogram times the specific heat of water, which in Celsius is 2.2 times 10 to the 3rd. and it's different from the value we used last time because this is in Celsius, not in Kelvin, times 5 degrees in Celsius. And you get something like 1.1 times 10 to the 4th joules. Well, we're not done yet, but I'm just going to stop the video right here, and please tune in for the next one, and thank you guys for watching.